For example, let me just give an example of a pH. Example of a pH. Sensors, they detect a variability of pH. So they just extract the changes in electrical signals that are extracted from there. And then the microchip reads that. So I wanted to know whether whatever the molecule, whatever the protein that we may, I don't know, the output, the end result of the binding that we are talking about, will it result into an electrical signal? But I'm
Yes.
sure somewhere,
Yeah.
somehow it might be. But now we have to then research further on the sizes of the electrical signals that can be generated there, and what best approach to extract them. Because some of the voltages are very small that you have to detect that this signal translates to this. You get the sense?
Right. No, so there's something called SPR, and it's a technique for detecting binding events, whether it's protein-protein, ligand-protein events, and it's basically something called resonance, which is basically measuring weight distribution across an electrical signal sensor. If you look up SPR, it is the basis of where this idea would come from, because it's basically
Okay.
translating weight into a heuristic for binding, because it's a change in mass event that happens
Oh,
that's tied to like an electrical signal. I have no idea how that's tied to it, but it is.
okay. Change of mass.
Exactly.
Okay, I get it. I am sure it's possible because from there, once we get the signal, the rest will be very easy. Yeah, nowadays we can easily compute and design artificial intelligence models. That will be very easy with the what we call Raspberry Pi. If you
Yeah,
heard
yeah, yeah.
about it.
Raspberry Pi. So then you can use that to definitely that will essentially be like your little proof of concept model, right? That captures all of this data, train the model, and then you can use that to basically predict new things that are related to farming and agriculture.